Hey there, this is Joey, and I'd like to show you this new project that I've just finished. So the problem this aims to solve is related to high-power rocketry. So in high-power rocketry, you often have avionics on board the rocket, and those avionics will be doing things like tracking the rocket's position and altitude and things like that. So you'll have it powered up sitting on the launch pad, but while it's on the launch pad, the battery on the rocket is starting to be drained, and if it drains too far, then the battery could die in the middle of the flight, which would be terrible. So the idea here is that this system allows you to provide power externally to the rocket while it's on the pad before it takes off. And crucially, this uses magnets to attach, and that means that you can easily remove the connector by just tugging on the wire, or even just leave it attached all the way up until flight and just have the connector break loose when the rocket launches. So if we look, we've got two parts going on. So the part across the top is finished, and the part on the bottom I'll be assembling right here in front of you. So the parts on the bottom, from left to right, first we have a simulated portion of a rocket body. So this is just a part I 3D printed because I don't have a body tube, and you can see it's got a radius of curvature, which in this case is 98 millimeters. So you cut a 20 millimeter by 20 millimeter hole in it, and then you insert the other parts. So this is a 3D printed component, which just has the right shape for the interface connector, and it just slots right into the hole here, and clicks right in just like that. And then into the back of that, inside the rocket, you put this tiny little circuit board. So it's 16 by 16 millimeters, and it's got a magnet on the front of it that'll go into the hole on the faceplate. So once that goes in, you've got that whole part assembled. So this is what goes on your rocket. Now on the outside is this. So you can see inline there's a fuse, and then there's an input, just normal XT60 connector, and the output supplying power to the rocket is another 3D printed part. So it's got the two terminals to supply power and magnets to stick to the rocket and actually attach to the other connector. So if I take the two connectors here and put them near each other, they magnetize, and just gotta get the orientation a little bit fixed, and there we go. So now theoretically this is supplying power. So of course we gotta test this thing out, so I made this little test setup. It's a bit of a mess, but hopefully I can talk you through it. So on the far left, the black and white object is the connector that we just assembled. Right below that is the XT60 that would be connecting to your rocket's battery, and then the red and blue wires are the output from my system, which then goes into a buck converter module that then powers the Arduino right above it. And the Arduino just has a script to flash an LED slowly at first, right when it boots, and then quickly after that. So that way we'll be able to detect if the Arduino has any upsets that make it reset, because it'll then go back to the start and flash the LED slowly a couple times. So now we're ready to test. On the far left is my power supply, which is acting as power provided by the Launchpad. Front and center is the connector to the battery that would be inside the rocket, and of course right above that is the main connector. On the far right is the multimeter, which is going to be measuring current draw from the battery power line. And then right to the right of that is my logic analyzer, where I'm going to be measuring the output voltage from my board to make sure that there aren't any hiccups when it switches between the two supplies. Alright, so let's test it out. I'm going to hook up this battery to power on the vehicle, so to speak, and we can see that the Arduino lights up and it also starts flashing its LED on and off every 2 seconds. We can see that the multimeter is showing that the battery is giving 22 milliamps, which changes a little bit when the LED turns on and off. And now the LED starts going quickly since the Arduino is through that startup indication. So we take our external power supply and we're going to slap it on there, and we can see immediately that the power supply is giving 31 milliamps now from the Launchpad, and the battery is having 0 current drawn from it. So now we're saving the battery. You can also see that there's a little light inside of the connector, and that shows that it's running on pad power, which you can see as the operator. Now if we take away pad power, it goes right back to the battery at 22 milliamps, and we can see that the LED is still fast, no issues. We can put pad power back on, switch back and forth as much as we want, and we can even launch the rocket with this on here. So I'm just going to yank on this, and we should see it switch to battery right away. There we go, perfectly fine, 21 milliamps. I don't know why it dropped, but whatever. And now if I just unplug the battery here, we can see that everything goes back to 0, as expected. So in order to make sure that everything was as smooth as it looked, I was logging the output voltage from my board the whole time. So the power supply gives 16 volts, but the battery is a 3S, so it's only at 12 volts. So the battery shows a little bit lower than the power supply. So here we can see the startup transient from plugging in the battery, which is short, and then we zoom in here to plugging in the power supply, and there's a little bit of a hiccup, but the big thing is that it never drops to 0, so always either the battery or the power supply are giving power. So we zoom in here on when I originally unplugged the external connector and it went back to battery, and that looks fine. And then we go back to plugging it in again, and there's a little bit of a hiccup there, but again, it's not a problem because the voltage never drops. And then here's when I yanked the connector away, and again, no issues. And finally, when I unplugged the battery, it decays to 0. And the big thing that we can see is that the system is always powered through that whole duration. There's just one final quick thing. So on this external connector, you'll see that in line here is a fuse holder, and that's just for safety. So inside there, I've got a 5 amp fuse, and this is just a normal automotive fuse, so you can replace it by going to any random auto parts store. And that's just to make it safe, because otherwise we've got the battery power going through this, and that external connector just has 2 exposed prongs, which could touch any metal object. It's also got a big magnet on it, so you don't want it like magnetizing to the side of your car or something and shorting out whatever is powering it. So just for safety, I've got the fuse in there, and you should be able to replace it pretty easily, but just gives some good safety. I chose a 5 amp fuse because the whole system I decided to design around 5 amps. So the PCB inside there, for example, I tried to make everything 5 amp capable, because that should power anything that you've got on a rocket that's just sitting on the launch pad. I think that covers everything. Please let me know if you have any questions or ideas for improvements. Thanks!